So we're given this circle, O is the center of the circle, and we want to know measure of AOB. Well, not actually the measure of it, but we're told that it's pi over something, pi over 8, and we want to find that A value. So we don't actually want to find the measure, but we want to find this A. So you see I've already made some sketches here to help illustrate the point. First of all, when it says angle AOB, you got to understand how it operates. So AOB, that creates this wedge right here. So the angle you're looking for is right there. So with that in mind, let's scoot over a little bit and draw a bigger diagram so that we can understand precisely what's going on. So since point A is shown to be square root of 3 comma 1, that means that, your square root of 3, that's your x value. So that means from the origin, we moved square root of 3 to the right. And from the x-axis, we moved 1 up, because this is where point A ends up. It's square root of 3 over and 1 up. So this creates a little triangle. And here we have, this is, the angle we're looking for. How can we actually proceed from here? Well, first of all, I'd say we should probably find the hypotenuse so that we can use some trig to figure out the angle. How can we find the hypotenuse? Just Pythagorean theorem, a squared plus b squared equals c squared, so that we know that the hypotenuse is going to be equal to the square root of 3 squared plus 1 squared is equal to, square root of 3 times square root of 3 is 3, plus 1 squared is just 1, so it's 3 plus 1, so that's square root of 4 is equal to 2. So 2 is the hypotenuse. Now, what can we actually make of this? Well, now that we have all the sides, we can throw in a little bit of trig. We know SOHCAHTOA, so let's just take sine. A sine is opposite over hypotenuse. So sine of an angle, some angle theta is equal to the opposite over hypotenuse. In this case, opposite is 1, hypotenuse is 2. So sine of theta is equal to 1/2. And here you got to use your knowledge of the unit circle to basically figure out that, well, if here's our sort of unit circle, we have 3 values here. We have, 30 degrees, 45 degrees, and 60 degrees. And since it's 1/2, 1/2 is the sine of theta, so that means that 1/2 is the y value. It's the lowest possible y value, so that's equal to 30. So in this case, theta is equal to 30 degrees. However, that's not actually what we're looking for, because what we want is A, because we want this in terms of radians, so it's pi over something radians, and we want the, over what. So how do you convert from radians to degrees? You simply multiply by pi over 180. So you got to do 30 times pi over 180. And conversely, if you want to convert from radians to degrees, you multiply by 180 over pi. Just think about it this way. If you're going from radians to degrees, you want to remove the pi, so you put it in the denominator to cancel out. If you want to move from degrees to radians, you want to add a pi, because radians are usually with pi. So you want to put it in the in the numerator if you're going from degrees to radians, just like we're doing here, so that you have it in your answer. So this is equal to 30 pi over 180, and this cancels to pi over 6. So that means if this is our measure in radians, A is equal to 6. And if you're watching this and you're feeling confused because you're not really familiar with what this unit circle is, you haven't really encountered this before, don't worry very much. This isn't a very common theme on the SAT. If you haven't ever gone over this, I probably wouldn't suggest that you use your time on this. If this is like completely foreign to you, then go ahead and just skip it for now and focus on other sections, because this isn't something that comes up too often.